Sorry guys, so this is where I left off. Okay, so continuing from here, we are supposed to change this chart to sorry, going by the changing unit of our axis. Okay, we are to consider consider changing the unit of our x-axis. So we'll use currently the x-axis is on pop n, okay, which is represented in thousands. Okay, but the actual billion, using the Kenyan example that has been given here, the actual population size when multiplied by 1,000 will equate 53.771 million. Okay, so now we are going to change the pop n figure from 1,000 to millions. Okay, then we'll round it up to the nearest million. Okay, so this is how I went through that. So sorry, so pop n, creating a new column called pop n m in millions. Okay, so it says we multiply the population value by 1,000. Okay, so this is the population value. We multiply by 1,000. Okay, so this is the value for pop nm, but we have to round it up to the nearest million. Okay, so I'll do it pop n m rounded. Okay, then I'll just put in the value round. I just want to round the whole figure. Okay, so I need one single whole figure. So this is the value. These are the values we're going to use to create our next chart, which should look something like this. Okay, so we will change the x-axis column from the previously pop n. Okay, from the previously pop n to pop nm column. Okay, then we'll select aggregate option and then we'll aggregate by average. Okay, so coming back to the chart, I'll use this. I'll change the value for x-axis. Okay, the value for x-axis, and then I'll make it pop nm rounded. Note that we are using the rounded figure. Okay, right. We realized there was no change in the chart because the figures are almost the same as the pop n value, the first one, just that we've only rounded it up. Okay, so the next thing we are going to do is, first off, we are going to use a smooth line chart. Okay, smooth line chart. So let me change this first into a smooth line chart. Then this is where the trick is. Okay, we realize that these values are in what's the name? Millions. Okay, so this one is 3,691,000, or better still 36,910,559. Okay, so the next thing we are going to do here is, for all the values here, okay, we are going to round them up to the nearest million, but we need a single value to represent it as, let's say, 1 million or 2 million. All right, well, this part, someone from the group actually gave me heads up on that, so let me move you through the steps. Okay, so we go to formats. First off, we'll highlight all the values under pop nm. We'll go to format, select number, and then we'll custom number format. Okay, we should note that this is the first one that I did. Let me just clear this. Automatically, when we come here, the value will be 0. Okay, but we want to have it in just one digit. For the function that he showed me, I'll explain that one further later, please. Okay, so we'll just put 2 commas to what's the name after the zeros, and then we apply. Okay, so in that case, we now see that the values has been changed from 0, from the whole lot into just the rounded million ones, the nearest million. Okay. Now coming back to the deck, it says that we should aggregate the x-axis, okay, and average it. So once we average it, we have our chart, just as expected in here. Okay, right. Now let's move on. For this one, we want to investigate what access water at different service levels looks like in specific type of areas. Okay, so over here, we will calculate the measures of central tendency and spread for our 4 national service levels. Right. So let's go back to our spreadsheet. We'll be using the estimates that we've worked on earlier. Okay. Right. So first, let's determine the maximum of each of the 4 national water access columns. Okay. So the maximum values, we all know how to calculate the maximum values, I suppose. So this is how we'll do it. We'll start from water base N. So this is water base N, right? So I'll put maximum here. And then, sorry, let me bring it down so that it doesn't include in that same table. Maximum. So the function is max, right? So these are the maximum values. Okay, let me go back to the slide deck. We see that our maximum for water base N exceeds 100%, which is not possible since 100% access means that every person in that country has access to the service. So we'll go back to the data sheet and create a new feature called water base N rounded. Okay, this way I'll just put it in front of water base N. I'll create a new column here. I'll call it water base N rounded. Okay, so this is what we are going to use, water base N rounded, meaning we are going to round the values in here to the nearest whole number. Okay. All right. So just as I did the first one, round, and then we select the value and we'll hit enter. Okay. So we are done with this. So now when we run the maximum value, we should be able to get just a constant number without any decimal. Okay, sorry. Okay, but there's a problem here because looking through, there are value features in the sheets. So going by the slide deck, this is what you say. So we realize that there's value error for maximizing from the maximum function. So what we'll do is we'll filter the water base round as stated here. We will filter it and then change the value columns to none. Okay, so let's filter water base N rounded. Okay, and then we'll only select value. Okay, then in value, we'll change all the values to none and then to none. So realize that immediately we change the 2 values to none, the maximum will change to 100. Okay, simplifying that, the maximum for water base N is now 100. Okay, it's now a constant figure without any decimals whatsoever. So let's move on and create the maximum for the rest of the, should I say, the functions or the tables. So we'll do for water limit N, water unimproved N, and then water surface N. Since we already have the function, we'll only drag it through and then we get the values for the rest of them. Okay, so the next we are going to create so after finding the maximum, we'll now create the minimum. Okay, so come here, type minimum. In this case, we'll ignore this since the value in here has decimals. Okay, so we'll use the rounded one. So minimum, and then the function follows. right? So just drag it through. Then we are done. The next one here is for a normal distribution, we expect that the mean, median, and mode would be equal. So let's calculate these features. Okay, so we'll calculate mean, median, and then mode. Okay, so to calculate the mean, we all know that mean is the average. Okay, so we'll take the average of the cell, and then we are through. Okay, let's drag it through. I'll also take the median, and then we drag it through. Then we take the mode, and we'll also drag it through. Okay, so mode. Okay, so we are done with that. We see that the mean, median, and mode are not equal for any of the four features. So let's also calculate the interquartile range and standard deviation. Okay, in Google Sheets, calculating the interquartile range, there's no formula for that. But we know that manually interquartile range is the difference between the third and then the first quartile. Okay, so we'll create a function for first quartile and third quartile. Okay, then third quartile, right? Then we'll do the interquartile range and then standard deviation. Okay, so first quartile, the formula, we just type quartile. Okay, we'll select the values in the data as we want. Sorry, select the values in the data as we want. Then we indicate the quartile number, in this case, first quartile, so 1. We are done with first quartile. Okay. We'll go through the same process to do the third quartile. We'll select the data and then come out with 3 because we want the third quartile. Okay. Then we'll do the interquartile range. In the interquartile range is the difference between the third quartile and the first quartile. Okay, so this is the interquartile range, right? And then we'll also do the standard deviation. Standard deviation. And this is the standard deviation. Okay. So we are done with this, right? Back to the slide deck. So this is an indication here that for water basin, we see that the mean is relatively high, and the interquartile range is about 1/10 of the range, which indicates that our data are concentrated around a point closer to 100% than 0. So this means that the majority of people represented in the data have access to at least basic water service on the national level. So water basin, on the national level, majority of people have access to what's the name? Basic water level or water service. Now we are going to create a diagram, box and whisker diagram. Okay, so visualize the 5 number summary for the 4 access features across different types of areas. But in order to do so, we need to populate the rest of the figures for the rest of the column here. Since we've already calculated, we'll only highlight the first one, which contains all the functions that we'll use, and then we'll drag it to populate for the rest of them. Okay. Now the next thing we are going to do is to create the box and whisker chart. Okay. Now this is how I did it. Initially, if I tried doing it directly by highlighting this cell, the cells here, and then selecting the box and whisker. But I faced some little challenges there, so I used an alternative method. Okay, let's see. Set column must be maximum. Okay, so low is minimum, high is maximum, open is first quartile, close is third quartile. But to select the axis, this is where I had a problem. Okay, so what I actually did was, let me delete this first. I'll copy all these values. Okay, I'll paste it as a normal value because this one contains functions. Okay, then I'll recopy these ones again, and I'll transpose. So to put the rows in columns and columns in rows. Okay, so I'll right click, paste special, and then transpose. So in this case, we have the minimum and everything coming to the row, and then the others following suit. Okay. Now, one other thing, we should know that the I don't even know how to say this, but we are calculating for water base for N, water limits, water unimproved, and then water surface. Okay, so let me just type those ones here. So this is base limit unimproved, and then surface. Surface. Okay, so it's the same for the rest, right? So once this is done, let's create the box and whisker chart. Okay, so I'll change this to box and whisker. Okay, then the low is minimum. Okay, high is maximum. Open is first quartile. Close is third quartile. All of these things are given in here. Open is first and then close is third quartile, right? So this is the chart that we are supposed to create. Okay, right. Now, I don't know if we can interpret this chart with the values in here. Okay, looking at the first quartile for water base N, the first quartile is around 85.5, and that can be seen somewhere around here. Okay, 85.5. Let me should indicate the values in here, right? So the first quartile is 85.5, and once you hover, it shows you all the details for every box and whisker, right? So this is how the chart looks like, and it's similar to what we've created. So let's move on. So the next one is to visualize the national access to water on all 4 levels based on the national population size. Okay, so we are coming to create charts to represent all the data we've been able to populate so far. Okay, so I think with this, let me I don't know if it's okay to use the same. Let me just copy all of these and paste them on a new sheet so that it becomes very easy for us. Good. Okay, right. So this is how it will be. Let me log this. Good. So now we are supposed to create a stack column chart for water base and water limit and water on and water surface N, right? But in this case, pop N will be the values on the x-axis. Okay, since we want to investigate how population size affects pop N will be an independence variable, and then these ones will be on the series. Okay, so let's come back here, and then this is how I usually do it. Okay, I put in the chart first. Okay, I have not selected any of them. Okay, let me delete this. We'll put in the chart first. We are going to use 100% column stack column chart. So let me change this to 100% stack column charts. Right, and then let's select the values. X-axis is going to be pop N. So X-axis, select pop N. Okay, we are done with pop N. right? Now with y-axis will be water base and water limit and water unimproved N, and then water surface N. So these ones we'll have to select. Okay, so this is water base N. We are using the rounded one. Okay, water base N. We are done with that one. Then we'll come to the next one, which is water lim N. This one. Then we'll come to water unimproved N. Then we'll come to water unimproved N. Then we'll go to water surface N. Okay. Water surface N. Okay. So this is the chart that we are supposed to create, and we have created. Okay. So let me just remove the chart title. We don't need this. It's not open. Right. So this is how it's supposed to look like. Just like this. Okay. So we can just change these ones when we change them at the top here. Right. So this is how it looks like for the first one. Okay. So this is the chart that we've been able to create, similar to what we have here, right? Okay. So we are now going to create the same chart again for pop U, right? And then I think the next one will also be for pop R. Okay. So for pop U, in order to avoid a messy bar chart, we are going to create a new feature called pop U rounded. Okay, so coming back to the sheet here, pop U, where does pop U start? Good. This is pop U. Okay, so we'll create a new sheet. We will create a new row, column. And then we'll name it pop U rounded. Pop U rounded. I don't know, pop U rounded. Then we'll round up all the values in pop U. Okay, now this is what we are going to use to create the data, the chart, sorry. So let's insert. We're also going to use the 100% stacked column chart. We are not using pop N, so let's take this one out. Okay, so now the x-axis is pop U, the rounded one that we just did. Okay, so let's highlight pop U rounded. Okay, and now the series are going to be all the values for U. So water lim U, water unimproved U, water surface U, and then water base U. Okay, so the first series, we are going to add water base U. The second will be water limit U. The third, I'm sure you understand what we are trying to do now. Third is water unimproved U. And then the fourth is water surface U. You click in the cell here, you select a column, and then okay. So now this is the chart that we are supposed to create. In this one, we don't have any chart to try to any visualization to compare it to, but following the steps in here, this is how it is supposed to look. So the next thing is that we are going to we are going to aggregate it to average. Okay, so once we are on here under x-axis, we aggregate and then we select average here. So this is how it's supposed to look, following the steps in here, right? This is how it's supposed to look. So we are done with pop U. Okay, so we are done with urban. Now the third one says you're supposed to do for rural. Okay, so the same thing we did for pop U, we are going to do for pop R. So we'll round up pop R. What is pop R? Okay. Now in this table, we don't have pop R, right? But we created pop R in the global 2020 report. So we'll come here and then we'll copy everything under pop R. Okay. We copy this. But before then, let's create a column somewhere. What should I even put it? Where? Let me put it here. Let me put pop R here. Okay. Pop underscore R. Okay. So I'll copy the data here. I'll come back to our sheet that we are using. Then I will paste. Oh, sorry. I have to paste value because the ones we copied in there had functions in them. So we paste value to only put the values here. Now the table is saying we need to round it up. So we'll create another column again and name it pop R rounded. Okay. Pop underscore R rounded. Okay. So we'll put in the function round, we select, and then we hit enter. So these are the values we are going to use to create the chart for pop R. Okay. So we'll go through the steps we used in creating the pop R. We're not using the scatter chart. We are using the stack bar chart, stack column chart, sorry. And then this is not what we are using. We're not using this as well. Okay. Now x-axis is pop R rounded. Okay. So we select and we'll highlight pop R rounded. And then the series is going to be everything under R, water base, R limb, R unimproved, R in surface, R. Okay. So we come to series, add series. Let's select the data range. So water base R first. We cannot highlight everything on the sheet. It won't work. Okay. Because we need it column by column. We can't, it won't work. Okay. So we select just one column first. Then we click OK. This isn't like Microsoft Excel, so we just move with it like that. And then we'll go to water limb R. We'll go to water unimproved R. And then we'll go to water surface R. Okay. Water surface R. Right. So for water surface R, then we are done. We'll also aggregate and average it. Okay. So we aggregate, then we change the series to average. So this is how this is also supposed to look. We don't have any visualization to compare it with, but following the steps, this is how it is supposed to look. So we are done with this one. Let's move on. So the next one is we are going to create a relationship between gross national income and then the groups. So for this, we'll have to create a pivot table. Okay, so we'll go back to our sheet. I'll use this same sheet to create the pivot table because we have the pop R in here and the others. Okay, so in order to create a pivot table, I will select the whole table, insert, and then pivot table, right? I'll create a new sheet. Then we are here in the pivot table. So for the pivot table, it says we'll create our rows to income group feature. This is very simple. So under rows, as we can see here, we only click add and then we select income group. We are done with that one. Okay. Then we'll come to the values. So the values are the sum of population size pop n. So under values, the sum of population size pop n. Okay. So we select pop n is under sum. So we are okay. And then the next one is the average urban share pop u. So we'll come back to values again. We'll add pop u and then we'll check average. Okay, average. Then we'll come again, average national basic share, limit share. All these are average, average basic share, average limit, average unimproved, and average water surface. Okay, so we add, sorry, this one was pop u. So we'll do base n, lim n, unim n, and surface n. So water base N, water lem N, water unimproved N, and then what's the last one? Water surface N. Okay, water surface N. Yes, so we are done with this, but all of them have to be in average. Okay, so we'll change it from sum to average. Sorry, this is supposed to be in average. Yes, so from sum to average, from sum to average, sum to average, and sum to average. Voila. So we are done with our pivot table. Okay. We are done with our pivot table. As simple as that. So we'll now visualize our summary data, but then we'll have to change the income group to reflect numbers instead of letters, because I think that will make the visualization very easy. Okay, so in order to change the values in the income group here, we can't do it in the pivot table. Okay, in pivot table, you can't do anything in there. So whatever change you want to do has to be in the set of data that you're working with. In this case, this spreadsheet. So what we'll do is that we'll come back to this sheet. We'll filter, we'll create a filter here. Okay. And then based on the narrations given here, we will change all of these values into numbers. Okay. So first pick none. But before we do this, let's use this step. It's very easy. Okay. Let's highlight this column. Okay. Let's highlight this column. Okay. And then we will hit Control F. So we are going to find and replace rather than what's the name, filtering it and then doing it one after the other. Okay, so we'll find none, and then we'll replace none with 0. Okay, then we will replace all. Please note that we are highlighting just this column so that the changes we'll do here is not going to affect any of the other cells. Okay, so we are done with none. Then the first one is going by the slide deck is low income. So we change here to low income, which is 1. Okay, then replace all. The next one is lower middle income. So lower middle income to 2. Then we replace all. Then we go to upper middle income, which is 3, and high income, which is 4. So upper middle income, which is 3, replace all, and high income, that's 4. High income, that's 4, replace all, and we are done. Okay, so once we come back to the pivot table, we realize that all the changes we did there has reflected here. Then the next is to create a visualization to convert the text income into groups and whatnot, at least any visualization that can make it easy for you to understand the table. Okay, so in this case, this is the visualization that I used. Maybe we can try and play with others to see if it will work. Okay, this is a column chart which didn't work. Okay, you can't really make any meaning out of this. This is a stacked 100% chart. That means stack chart, it doesn't make any sense. That would be the same for bar chart. For line, will also not make any sense, right? Because the average values are very smaller than the sum. Okay, and then this will be the same. So let's stick to 100% stacked area chart. Okay, I think this one gives some clear indications, and then we can really make some sense out of it. Okay, so looking at this, we can find this is POPU. This is the value average for POPU, the population under urban. This is for water base for the national water limits, and then all stuff. You understand? So why do I have POPU here? Okay. Average urban share. Right. Cool. So we are done with the visualization. Okay. From this we can make a lot of sense looking at the data we already have. Okay, so the next one will be summarizing it. Okay, so I think that is all for how to create a visualization and stuff. Hope this will really help most of us in here. Thank you so much, and you can chat me whenever there's any challenge. Cheers.